Hey, welcome back. Good to see you again. Thanks for joining. Today on the bench I have a Nakamichi Receiver 1. This was brought to me by my client, and this has a little interesting story, this receiver. I was looking on our local buy and sell page here. We got Kijiji in Canada, and I saw this receiver pop up, and it was for a very attractive price too. And I was thinking maybe I should go grab it. It was that good of a price, but back then it was minus 35 overnight, minus 30 in the daytime, and I really was kind of weighing up my decision here. Well, should I really want to go out and start the car and let it warm up for 20 minutes, and then drive into the city and meet with this person, and it would be, an incredible hassle getting this, but I just let it go. And then a few weeks later, a picture of this popped up in my email from one of my clients. And I guess he saw it as well, and he bought it. And good on him too. It's a good score. This is a nice, very nice unit, and he's very pleased that he picked this up. Apparently it works. It's got audio on both channels. The problem with this is it has no display. So we're going to have to dig into it and find out what's wrong with the display. Apparently it does have the remote. It comes with a remote, and I think he did get it. So let's we're hooked up to speakers now, and I do have my tone generator connected. Let's plug it in and see what we get for display, if anything at all. Okay, so turn this on. We got a green blinking light. Now it's steady. Okay, I need CD. Audio mute. Where are we? Why don't we have any? Audio output. Oh, I gotta turn speakers on probably. Let's see here. Speakers. A plus B. Let's go for A. Variable loudness, balance, record out. Okay. Not getting any audio through this. Let's try it on a different input. Okay, let's go for video 1. It's quite heavy. Not getting any audio whatsoever. Nothing on tuner. Where is AM, FM? Getting any audio at all. Okay, let's pull the lid off and see what's going on. Alright, we're in. Yes, power switch is a Kerchunk, and it's on the primary side, so I'm getting a lot of buzz from this transformer. It's a big transformer. I don't know if you can hear that. Kind of not normal for a stereo to be making, transformer to be making noise like that. Up here we got power supply board, it looks like. Some fuses on there. I'm going to check some of these fuses before I go too much farther. Great big heat sink in the middle. It's got a big U-channel extrusion, aluminum, and then it's got fins attached on both sides to dissipate the heat. On the bottom we have our transistors. It's all discrete. So we got your transistors mounted from underneath onto the board. Power power amplifier section here. Power amplifier section here. Looks like they have the power supply for the amplifier up on this little video board. I don't know why they would do that. That seems kind of odd. But if I follow the wires from the transformer, they do come here, and this is your 3 wires, your center tap and your 2 windings, and it goes into this bridge rectifier and a couple of big filter caps. Those are 10,000 microfarad and more than ample enough for this. And then the power goes down onto the amplifier board. Got one area here that's cooked. This looks like a couple of Zener diodes. Let me point these Zener diodes out to you. There's one here and one here. And this whole area looks cooked pretty good. So these transistors are probably flapping in the wind. If I look underneath, the solder connections might be loose or cracked. Everything else looks intact. Looks hot's not glued, dripped over here. Everything's holding. It doesn't look like it's been worked on. I don't see anything that's been played around with or tampered with or changed. So let me pull the bottom off. Have a look at the bottom too. So I remove a 2/3 plate on the bottom, and it reveals all the transistors for the power amplifier, bottom end of the heatsink, and pretty much access to everything on the bottom of the main board. There's a few connections you can't reach back in here, but for the most part you got full access, which is good. What do we got here? We got Sanken's 2SA 1492s and 2SC 3856s for output pairs, complementary pairs. It's nice beefy transistors. I can't remember what this was rated at. Was it 90 watts or 60 watts a channel? I'm not sure. But yeah, it's built for fun. Okay, so let's have a look at that power supply board and see if we can find any going on there. Okay, so some secrets are starting to be revealed. Now I kind of thought something was going on when I took the cover off. They had non-standard screws for the cover, like somebody put the wrong screws back in, or maybe they replaced them with something different. But look at this power supply board wasn't even connected. It's kind of floating in space here. If I can get it out. Nobody cut zip ties yet, so that's a good sign. But there's definitely a screw missing here. There's a screw missing here. And this was put together wrong. Just out of, see, it just comes out. So I wonder what's going on here. Let me see if I can get this out. Somebody had this out. And they didn't put the screws back in. There we go. Yeah, this screw is missing, and this is a ground. That is a ground connection. Let me have a look here. And there is one fuse here. I was going to pull this fuse out and have a look at it. Or better yet, I'm just going to meter it. I'll just meter it with my continuity tester. It shows it's closed at 1 ohm. Yeah, 1 ohm. Let me see this fuse. Try this one more time. Yeah, the fuse is still good. So what is going on here? Unplug this. So I'll have a quick look at this stuff. Here's a relay here. I'm wondering if this relay is a power relay. 2 relays back here. Now I didn't hear any relay clicks when I powered it up, so I'm assuming the relays are not clicking in. And this is on the speaker output board. We've got speaker connectors, a couple transistors, 2 relays. There's some resistors here. I believe those are probably for the headphone, dropping resistors for the headphone output jack. Yeah, so we got little problems here we gotta have to deal with. I'm looking at this. Let me cut some of this stuff off. This is kind of a pain. Now we can have a better look at some of this. Some of these capacitors are pretty low quality. They're Jamicons, Chinese capacitors. Luxon. There's no name brands here. 1500 milliamps. Okay. Alright, so I did look and I cannot find a service manual for the receiver 1. But I did find for the receiver 2 and the receiver 3. I don't know how similar they are in design or circuitry. So I'm going to have a look at that and see if this parallels a lot of what's on these those other ones. It looks like somebody opened this up and had an attempt at repairing it or maybe doing something, but they didn't put it back together properly. Okay. Can't see it from where you are, but there is a lot of circuit glue that's spread across this board. It's all splattered all over these capacitors here. So that could be part of our problem if that glue's become conductive. It looks like they used a combination of hot snot in a lot of places, and then this circuit glue right here, it's really prominent. There's a lot of circuit glue on all these 4 or 5 capacitors here. Alright, so that buzzing I'm hearing is actually coming from the speaker relays. Or maybe it's this transformer. Could be from this transformer. Yeah, this is buzzing here. This has got a little bit of a screw missing. Here's an anchor screw here. An anchor plate. And that's what was buzzing. Okay. So we know that's not the speaker relays. I thought it was. But let's check the outputs of this. I don't know. I don't know if this is, let's see here. I don't want to get shocked grabbing this thing. And we got let's try this. .6 volts, 4.79 volts, 5.04 volts, and 0.9 volts. This here should be 120, 123, and the output should be 12.0. Okay, so this is a little power supply for what looks like the remote and the CPU and all that stuff. I did a few spot checks on this board and I didn't see any bad capacitors. I'm going to go through and make sure I do a full check on all of them, but so far so good. Didn't see anything bad with the capacitors on the power supply board. Okay, I think I made a little progress here. I'm checking these voltage. There's two voltage regulators here. One's a 5 volt. This is a 7805 5 volt regulator. And down here we have a MC7812C, which is a 12 volt regulator. Let's see here. I'm just trying to look. But I'll show you what I see when I try testing. You can see that. Hope you can. Oh, I'll put it over here. Okay, turning this on. Which one's clicking here? Is it this? Yeah, this relay's clicking. That's good. Because that's supposed to click in the main transformer. I'm just wondering if there's a fuse blown for that main transformer. I don't see any fuses here. I'll get to that in a minute. Okay, so voltage checks. Here's the 5 volt regulator. Let me attach to ground. And this is the input. Got 13 volts input. And the output is a rock steady 5 volts. Okay. So the next one is the 12 volt regulator. Let me try and get a ground here on this one. Okay. Pin 1 should be input, and I got 0.8 volts. Pin 3 should be the output, and I have 1.2 volts. What's going on there? Good question. I have to trace back. That's a capacitor, that's a capacitor, and that's a capacitor. How is it getting fed 12 volts? I don't see anything here. This, what is that? A jumper that's missing. That's really odd. Capacitor there. Capacitor there, capacitor there. No power feed. How the hell is that being fed 12 volts? That just doesn't make sense. Oh, that's the bridge. Okay. I thought that was a capacitor, but it's not. It's a bridge. Okay, let's check this bridge out then. Maybe this bridge is bad. Here's our fuse. We can check the voltage across that, and we have pretty much nothing across that fuse. But if we go from the fuse to here, we should have fuse 0. The two blue ones are 0. This is the primary here, I think. I'm going to check that. Maybe we have an open thermal fuse on this transformer. Let's check this. Okay, this wire here. There's a hidden fuse here that's blown. It was hidden under this card. Okay, that makes sense. So we now know what's going on. Let's see what we can do here. Five amp, 250 volts. Okay, so we should check to make sure we don't have any shorts on this. Let's I'll go through and do some continuity checks and I'll check a lot of things here. I'll check these bridges. There's a bridge here, bridge here. Something's got a short happening. So we'll check it all out, make sure that we put a fuse in, it's not going to pop again. So from the looks of my diode checking here, it looks like we have a couple of shorted transistors. This output transistor here, this 2SA1492, and the driver is 2SA957. Those both look shorted. And this one looks damaged. I'm not really seeing. Maybe you can see this as well. Let's check this one out. This one doesn't come up with proper numbers. Let me see here. That is, this one's the one that's shorted. That's 0. That's the base to collector, base to emitter, 0. Pretty sure that's a short. Base to collector on this one, shorted. Base to emitter, looks open. Looks open. Looks shorted. So this one here, it looks open. It shouldn't go up above 0.6 volts. And then this one, that one looks normal. This looks open. Okay, let's try this one here. Base to collector. That looks open. Shouldn't go that high. And that looks leaky or shorted. So we might have a problem with all these transistors here. And I have a feeling I know why too, because a lot of these drivers and some of the circuitry here, I can see some crack solders. And I don't know what this is here. This is those two Zener diodes. And there's 4 power transistors around it. I think it's some kind of a power supply for local use. But this here, I'm pretty sure there's some cracks going on here. And pretty much all around here is cracking. Some of these joints are cracking. But yeah, Looks like we might be putting some new silicon in this thing. Alright, so I think I found out the cause of the destroyed output transistor. There are some transistor leads here that are completely cracked. I can see them here. There's one. This one here. It's on the fringe. There's some other ones here. If I look, yeah, these two transistors here are pre-drivers, I believe. And one of them is definitely cracked. It's kind of buzzing there. This area here with the heat, I kind of cleaned it off a little bit with alcohol here, and it looks a lot better, but somebody went in here and resoldered all this, so this is all good. But they didn't resolder a lot of other things. There's other cracks here. Another big thing I'm finding is these switches. There's a switch here. This is the tone defeat switch. These are all cracked here on this switch, and some of these potentiometers have cracks around them. I guess there's a lot of play between the main board and the front panel. That's what causes these cracks. If you get any movement whatsoever, if they're not completely solid with each other, you get movement, then you get cracks. So I'll go through and fix all that up, but I have to remove this part I can't get my iron under there. So I'll resolder this, and same thing in this channel. This channel has cracks as well. Been looking here. Doesn't look as severe, or maybe somebody touched them up. But this is the survivor, and this one's the dead channel. I only found one transistor so far, and it was the 2SA1492 that was shorted. The 2SC3856 seems okay, and the two drivers seem okay, and the thermal tracking transistor seemed okay. So I'm going to make sure I'll check these over again and check them all over. The two emitter resistors are okay. So usually when you get a transistor that shorts, well, transistors can have many fault modes. One of them is they can go open, and then the other one is they can go shorted, depending on which leads they short between. And usually when a transistor goes short, it dumps the rail voltage into the internals of the amplifier and causes more damage back farther. But I'm not seeing that right now. I'm not seeing it on the drivers, and I'm not seeing it on any of the other ones. But like I said, I'm not done looking here, so I'm going to continue. Power supply, I recapped probably half of it. The bigger capacitors tested all fine, and I left them alone. And then I mounted the board properly. It's screwed down this time. It's not just flopping in the wind, and everything's good. This power supply I removed and had cracks on the bridge rectifier, believe it or not. And this transistor here was cracked as well. But this transistor is a series pass regulator for this little bit of video circuitry here. This there's a little power supply. These two white wires come from the transformer, goes to the bridge rectifier. There's some capacitors and a transistor to regulate that. And then it just feeds these little circuits here on this board. I think that's up to here it feeds. And that's all fixed now. I put a couple of capacitors in here because they were really weak. Haven't found any failed capacitors except for one on the power supply. The other ones I replaced, they were getting weak, so that's why I'm changing them. I'm looking here, and I did change two here, capacitors, because they were weak. But I'm not done yet, so like I said, I'm going to go through and check all of these, and if they pass, they pass. I'm going to leave them alone. If they don't, well, out they come. And yeah, so we should get this going, no problem. I do have transistors, brand new ones. I bought them just a few weeks ago, around the new year, and they're in, so I can put those in, and then I'll have to remove this assembly to get at these solder joints here. Alright, got the front panel off. What I did is I removed a couple screws here. 1, 2, 3, 4 nuts off the controls, another screw, 2 more screws, and this liberates the front subframe. I can now move it away, and I can jam it open with something, and then I can go and solder these. These are all cracked. Believe it or not, every one of them has cracks. Volume control, tone controls. So I'm just going to go through and resolder these. It's a surprise that sometimes when I see cracks that are this bad, I just like, how does this piece of equipment work with all these cracked joints? Same goes for the input connectors on the back. They always crack too, especially if you get the ones that are being used frequently. The stress when you plug it in and unplug it can crack the joint. The solder is not really, it's really soft, and it's not meant to be a mechanical connection. It's just meant to electrically bond each other. Okay, I think this switch is all cracked too. This is the tone defeat. And just get this quickly soldered in. Where was I? Oh yeah. I'm using my big chunky solder today. Anybody notice how expensive solder has gotten lately? I went to buy some. What the hell was that? I went to buy some off AliExpress. This stuff here. Don't buy this, it's garbage. It's like lead wire. It doesn't even work. And I wasted money on it. But you know, you go through reputable brand and get decent solder. Don't go cheap on it. So now I got a couple rolls of lead wire that I don't know what to do with. I asked for a refund, but they're ignoring me, so it's expected. Okay, I think I got it. One more here. It's not the prettiest thing, but it works. Okay. There's some up here too. What is this? I think it's a connector. Okay. Alright, I got transistors in. I got everything connected back up again. I hope I got it wired in right. These cables there are not very well labeled. Okay, so what I'm going to do first is I think I'll put a 2.5 amp fuse in and see if it boots up with a 2.5 amp. It should. I'll just start easy. Let me see if I can get this in. Well, I could make this more awkward. Fuse holder that's pointing the wrong direction. Get in here with a glass fuse. You've got no place to put your fingers. Okay. Alright, power switch is off. Let's plug it in and see what we get. We get a smoke show. Okay, here we go. Fuse is intact. Green light. No display. I'm getting a relay click. Where are we getting a relay click? Here. I'm getting a relay click there. We're not getting anything. Back to the drawing board. I'm going to... something is still not right with the power amplifier. Let me do some voltage checks on the outputs as we power it up. I'll see if we have any heavy DC offset. So what I'll do is I'll just connect the voltmeter to the collectors and the speaker outputs, and we'll monitor that. Alright, first test. I got my voltmeter collected across both collectors of the channel. We are going to check and see if we have our voltage rails on those transistors. Let's plug this in. 100 volt scale. Let's turn it on. There we go. We got about 120 volts. Okay, so that's normal. Let's check the other side. Turning it on. We don't have the same current here. Oh yeah, we got the same. 120 volts. 110 volts. Okay. So that part's good. Now we are going to check for voltage on our speaker outputs. Where is ground? I guess we're just going to go with the chassis here. Okay, speaker outputs. Need to figure out where the speaker outputs are. Speaker outputs are right here. Okay. Turning on. Yeah, that's 0 volts. That's good. Okay, the other channel. Zero volts. That's good too. Okay, everything's normal on the power amplifier. Just wondering if we have a signal going through. I'll hook it up and see if we can get a sound out of this thing. Yeah, I had the connection plugged in the wrong spot there, so I think I got it sorted now. It's got a mess of wires. So let's turn this on, and I think it's working now. One click. And the relay's clicked on. 2 clicks. Okay. Okay, we need CD. Which one's CD? Can't remember. It's this one. What is going on here? Tuner. Let's try tuner. That appears to be working. AM, FM. AM. FM. Oh, it's tuner. FM. Still have no display. I don't know why it's doing that. Okay, let's go back to tone. It's supposed to be on CD. CDs, oh, this one, there's CD. We have a problem with it. Okay, let's get that voltmeter back on the, it's the right channel that's causing problems. Let's try the left. Same thing. Okay. Let's see what we got for DC on our outputs. Everything's cold. That's good. It's a good sign. All right. So here's one channel. Turn down 3 volts. Interesting. The speaker switch doesn't work. What's going on with this?
Un matin en 2006, je me souviens, j'étais chez moi en train d'écouter la radio. À l'époque, c'était France Inter. Et j'entends...
The mute was on. Something not right with his loudness control. Alright, so I had a little sleep on this last night and thought about it, and I have a feeling I'm missing a power supply voltage. The reason I'm saying that is because, for the most part, I think our power amplifier is working now. It's getting full rail voltages and it's passing a signal, and it's not heating up, smoking, sparking. So I think it's working good. I think we have a missing voltage that controls the preamplifier and probably the display unit. We do have our 5 volts because when I was adjusting tuner, I was able to switch channels and switch bands, and I'm able to switch inputs using the soft touch buttons. So all that circuitry is powered up and working. the mute was working, everything's working there. So you know, we do have 5 volts. We know that because we tested that and we have 5 volts. So that 5 volts is probably running all this control circuitry. But I remember I tested here and I was looking for 12 volts and we didn't have 12 volts. We had something like 0.8 volts. So that got me thinking, how come we don't have a voltage? So then I went on the look and we found this fuse blown. And now that I look at it, this fuse powers this transformer. These blue windings coming from this transformer go back to that 12 volt regulator. So if the relay on this board if the relay on this board is not activating, then this transformer will stay dead. If this transformer stays dead, we'll always have no 12 volts, which is fine. We have that fixed now. I'm going to replace the 2.5 amp fuse with a 5 amp fuse, if I can get it in there. And then we'll test it for 12 volts. And I do have this unplugged, so I'm not going to zap myself. So I'm just going to go in here and put this fuse in, if I can. It's really awkward. Okay. Now we can plug this in, and we can test for 12 volts. We should have 12 volts on our 12 volt regulator if everything's working good. Okay, let's turn this on. Okay, we got a second click. So let's see here, pin 1 should be the input. And we got 18 volts, which is good. And that's the output, 12 volts. Okay, so we confirmed that 12 volts is good. But that's not the cause why we have no display. Nothing. Now, next on my list to check is this business here in the middle. This to me looks like voltage regulator business. We got Zener diodes surrounded by power transistors. We got a couple of huge dropping resistors, 220 ohms. So I think what they're doing here is they're taking the B plus rails and they're dropping it down to probably a plus minus 15 volt supply or something. That's what my guess is. So let's see if we have anything here on this setup. Let me see if I can get a look at this. I don't know where. Let me just ground here. And probably what I'll do is I'll just check these resistors first. So there's one. Yeah, we got 54 volts on that side, 40 on that side, which is good. There's a voltage drop there. This one here, 54. That was negative 54. Yeah, okay, negative 54 plus 54. 39. Okay, that's working. So what do we got here on the collectors? Okay, I'm just trying to see what's going on here. I'm checking the Zener diodes now. Okay, that's one side of the diode. The other side, you got 18.5 minus 0.5 minus 18. Everything looks like it's working on the regulator so far. Okay, 18 volts there. Starting to get warm. I'm going to plug this in. This is the filament for the vacuum fluorescent display, and I unplugged it because I was checking the ohms. This is about 9 ohms here, so I know I got continuity. And then I checked continuity on this connector, which goes to the transformer, and it was like 1 ohm or less. So I know I have voltage there. So I'm plugging that in. And we still have no display. Now, I did take out the front panel and removed the circuit board here and resoldered pretty much anything that looked suspicious. Typically when you have a vacuum fluorescent display that goes out like this, if you pull the vacuum fluorescent display tube and look at the solder connections for the filament, you'll see that they're cracked. And usually they're on the ends, right? The ends of the tube where they get maximum expansion contraction forces. They usually put the filament terminals on it right on the end, and that's where they crack first. So typically that's what you look for first, but I didn't see that. I soldered it back up. I think we still have a fusible resistor that is somewhere here open that is stopping one of my supply voltages. Now, the trick is just finding it. Okay, I need to get a sense of where these power rails are going and coming from, because I have no documentation on this. There's a connector here beside these regulators. Let me see what this says. 29.6 positive, negative, nothing, and 12 volts. And that comes from, this cable comes from the power supply board. Okay, I don't think that's a power feed for our regulators here. This though is, this plus minus 55 volts. Okay, but where does it go? That's what I want to know. Here's a cable that runs to the back, and it says minus 18.5, 0, plus 18.2. Okay, so that's one feed, but that goes to the back here, and it goes underneath. Probably supplies power for all of the input switching and audio. So maybe that's where I need to go back here and look, because on one side I have 18.2, the other side I have 18.5, which suggests that maybe one of these could be open on this. So let me pull this power supply board out, and I'll check underneath it for any fusible resistors. So I'm just trying to figure out how this board gets fed power. I think when I had it out, I looked at it, I didn't see any obvious power supply section like regulators or conditioning. I just saw a bunch of buttons and LEDs and you name it. So let's take this board out and have a good look at it again. I think I can just pop it up like this and separate it from the rest of the plastic. Now I got the headphone connector here. I'm just going to put this aside. Oops, I'm be careful with those buttons. So where is the power coming in here? There's a choke and a cap here, so that's probably obviously where it is. And that is, no, it's not that one. This wire here. So let's measure and see if we're getting power on these wires here. These four. Okay, let me plug this back in. Turn it on. Blinking light, steady green. Okay. So what do we have here? We have nothing. 18 volts. Nothing. 1.8 volts. I think we're missing our negative supply here. Hang on. What is this? Nothing. 18 volts. 0.6. 1.7. 1.7. Okay. Something with this diode here. I'm going to have to flip this up, and I'm going to have to read the diode, read the PCB board, and see if it even does get a negative voltage up here. I'm not sure if it does or not. Okay, that's 5.6 volts on that choke. This cap, 5.6 and 0. 5.6. So we do have 18 volts coming here, but where does it go? Let's go to this chip. Big chip under there, big massive thing. It's got like 64 pins, I think. Alright, I think I'm making some progress here. I got the schematic. This is for the receiver 2, Nakamichi. And I don't have a schematic for the receiver 1, but I'm looking this over, and a lot of similarities between the two models. This is this display and control printed circuit board. It uses the same chip, fluorescent display, key matrix, everything's the same. And then going on to, let's see here. I was looking at this, and there's a minus 30 volt supply for the vacuum display unit, and I'm just going to check and see if that voltage is here. That comes from the power supply board. The power supply board is this board here. So this supplies, there's a separate winding that supplies a voltage. There's a fusible resistor, there's a single half-wave rectificated diode there, 1000 microfarad 50 volt cap, fusible link, and that is 1 ohm, I think it is. It's FR401, and then it goes through a transistor which regulates it down to 31 volts. There's a zener. So it's a little simple circuit regulator. Minus 31 volts coming out, and it goes to, oh, there's also a plus 30, plus 12 volts, plus 30. Oh, that's interesting. I'm gonna have to see where that one is. Yeah, the minus 30 goes out from here, goes to the display board, and that's this cable here. It's 5 conductors. Let me see here. So it should be ground, plus 5.6 volts, relay, power on signal, and minus 30 volts. So let's check this. Turn this thing on. All right. I got our relay clicks. That's another thing that's concerning me is these switches have no effect on the relays for the speakers. So there's something's not connected here and not going through. So we're going to have to troubleshoot that as well. But let's first see if we have plus or minus 30 volts here. I don't know which pin is which, but I'm going to just test these 5 points here. So there's one of them. Got 1 volt there. 5 volts there. 4.8. 5.6. Okay. And this one is 0. That one is supposed to be the ground. The ground is beside the 5.6 volts. But on the opposite end, I should have minus 30, and I have 1 volt positive. So what does that tell me? It tells me the 30 volt supply is out. Okay, so we're going to have to remove that power supply board again. I know I secured it down, but I'll pull it out and we'll have a look at it. Okay, so I got the board out here. Let's have a look at fuse FR401, sorry. And it's kind of buried here beside this relay. It's a 1 ohm. And we have 1 ohm. What is going on with this thing? Okay, our transistor for doing the regulating. Let's get the sheet out here. Transistor for regulating is Q405. D401 should be right. Where is D401? Right here. Maybe this here. This is the power feed here. This is the brown windings. Let me check and see if we have AC on that. I'm just going to make sure this doesn't short. Get on AC. Plug this in. You can see why a transformer wouldn't put out AC voltage. Okay. Let's start from the beginning here. So we got 31 volts AC, okay? And that comes through there. What is that? That is a capacitor. You gotta be careful. I got 120 volts on this. Down here, yeah, don't want to touch anything that's. Okay. Okay, this is the diode here. I'm just going to check it. Could be open. No, it's not open. So this should be DC here. Let me turn this back on. Can you see everything here? I hope so. Alright, so if I go from here to here, I should get a negative voltage. But I'm not. What is going on with this thing? Is that diode bad? Is there voltage across this? That is weird. You know what? I think that fusible resistor is right here. I'm going to have to look at this circuit. Something doesn't make sense here. All right. There's our transformer supplying 31 volts AC. There's our diode that's not seemingly conducting any current. But it shows good. And then there's a capacitor across it that goes to this fusible resistor, which is 1 ohm. And then from there it goes to I can't tell if that's a collector or emitter, but Q405 is this one here. There's a Zener diode here. It looks, I dug it out from the glue. Let's see if we have anything on the Zener diode. The Zener diode is open. No. Is that what's gone wrong with this thing? No. Here, I don't know if this transistor is at fault. Let me check it with my diode checker. It should be emitter collector base. Or is it? I don't know. Transistor looks good. Something's not with this circuit. Something's not working. Okay, let's try this again from the beginning here. We're not getting any current going through this little power supply, and I'm just really confused as to what's going on here. So let's get AC volts, turn this thing back on. Okay, there's our clicks. Here's our input voltage. 31 volts AC. That diode is not working. I am not getting any DC on the other side of that diode whatsoever. Even though it shows a good junction. I'm getting AC through it because there is a capacitor. That is really weird. I'm going to pull that diode out. Maybe that's broken there. I got a broken foil trace. Maybe that's the cause here. Hang on. Alright, I repaired this dodgy looking trace here. Put the jumper in. Let's see, turn this thing on, see what we get. We get a display. Should have our minus 30 volts now. Oh, look at that. There it is. Run CD. Very good. AM, FM, phono, CD, video. Yay, we got it working. Okay, let's put some stuff back together here, and then I still want to test it. One thing I need to do is I need to replace this backup battery. This is just a Sanyo lithium ion, or not lithium ion, but lithium cell coin battery. So let's see what it shows here. This is for the memory preset. So yeah, we got a tenth of a volt. So that one's kaput. So my plan is just to put one of these coin cells in. 3.1 volts. We'll tack a couple wires onto it. I know people don't like tacking wires onto batteries, but I do it all the time. It's not a big deal. First, this is the positive, right? That's right. I don't think it is. Can't remember what it said. This is positive. That's negative. Okay. Okay, negative on top. All right. Let's just give this a little scratch with a scour pad, just so that the solder sticks a lot better. And we can even put a little flux on here. And we'll tin this. Now, let me clean my iron. Trick is getting really fast and hot with the heat. And it should be all right. Okay. Something on the other side. It's going to cool this battery down. It's getting quite hot. Probably left the iron on too long. So what does it say now? It should be the same. 3.1. It's not going thermal on me or anything. I just need a little time to cool off. Okay, we'll scratch the back. Give it a little bit of flux again. Okay. Very quick. Now, what I'm going to do is I'm just going to put it in the sleeving. This is heat shrink sleeving for batteries, battery packs. Let's see. Put this in here and I will heat this up. That should be good just to insulate it. Okay, now I can put that in the circuit. Alright, we're all back together now, and I'm going to do a power test here. Got everything, I'm pretty sure everything's done. I went through and checked a few more capacitors. I changed 2 more, and the rest were fine. Bolted everything back together, replaced the backup battery. Haven't done anything with the pots or switches yet, so I'm kind of curious as to how they sound. We haven't heard this thing running yet. So let's power it up, feeding a 1000 hertz tone, and you should be able to see the scope. So let's turn this thing on. Okay, another clicks while our relays are on. Where we were on FM, we want CD. We're plugged into CD, that's right. Okay, so let's turn it up. We are not getting a signal, a strong signal anyway. Those are tape monitors, are all good. Speakers A. We might still have a problem with the amplifier or the preamplifier. Okay, what is going on with this thing? Something going on with the tone circuit. Alright, let's feed our signal directly into the power amplifier. Make sure that is working first. Let's turn this down. Okay. I'm just going to reconfigure the wiring here for the power amplifier. Turning it up. There's clipping there. Okay, let me back this off and adjust this for... Let's do this again. There's clipping. Back it off. Right to this point. Getting 27.55 volts RMS on the output. We're getting full power. And that's the left channel. Let's turn it up and let it cook for a while. It's actually 28.51 volts RMS. Let's let this go for a while. Okay, I think this has been on for 5 minutes now. I'm just going to turn it down. It's proven its point. It's working good. The power amplifier is working good. We still have a problem with the preamplifier section here, I think. Okay, so I was kind of confused as what was going on with the preamplifier. It seems like it was getting weird results, but then I hooked it back up again and I plugged it together and tried it out, and here it is. It's working fine. You can see I can take it all the way up to clipping. Getting the left channel, I can measure the left channel at 28.8 volts RMS. Looks like the right channel is clipping a little sooner. Square wave, let's try a square wave, and it looks good. Turn the tones off. There's the tone off, tone on. Treble boost, treble cut, bass cut, bass boost. Everything's working good. So this is done. I'm going to wrap this up. I'm going to put it back together and give it a listening test for a couple weeks, and then I'll give it back to its owner. So it looks like it's a nice, very nice unit. And yeah, I missed out on this one, but I got to work on it anyway, so that's good. So thanks a lot. Thanks for watching. Talk to you later, and take care.